Hey there, and welcome back to the Orkestra YouTube channel. Thank you so much for tagging along once again. And also, I wanted to take a moment and thank everyone who has shared some positive feedback or response after the first episode was published. That was a really great feeling to see that the community was welcoming this, and it made me want to do more. So let's start right ahead with this episode 2. And I will be publishing one video per week throughout the upcoming month. And all these videos are going to have sort of a logical flow between them. And in this episode 2, we will be building an exploded axonometric tool with OkPy to go from any Revit building and build something that looks like what you can see here on the right of the screen. The goals for this episode is to build an actual reusable tool with OkPy, something that you could hopefully include in your company workflows to make some cool presentations of your buildings. You'll see that the combination of the three tools that we'll be building in the February videos are going to be a pretty powerful combination and time-saving features. We're going to be building OkPy inputs and see how we can share them online. We're going to learn about the Revit API and also some Python. And there's going to be a couple of tips and tricks that will be shared here and there. So hopefully you'll pick some of that up. The steps for this video will be to first pick a reference 3D view where we set our extents and our angle. It just is nicer to set it up through the Revit UI and then use that as a reference to build the rest of the views. Then the second step will be to get the ordered list of levels that we have in the project. In the step 3, we will create those views like slices in the model and adjust their extents. And then finally, we're going to stack those views on a sheet and make something that looks really cool like this. All right, so for this video, we're going to be in Revit 2023 and we will be using OkPy from Orkestra 1.610, which is the most recent version of Orkestra at the time of this recording. We're going to start right ahead. If you haven't watched the previous episode, please go ahead and do so because it will make much more sense to you then, because I won't be covering all of the conceptual stuff of OkPy in this video. So yeah, just going to start with a new tool using an OkPy tool template for Revit and hit the create button. That will generate a new project with a couple of lines of code with the first part that's basically the most relevant imports for this exercise and building a Revit tool in general. There's also a couple of useful built-in variables that will help us interact with the current document and application in a pretty easy way. So what I'm going to do here and what I like to do in general is use some comments to describe the steps that we are going to be going through. So starting with step 1, which is getting the reference 3D view, just like we described earlier. Then get that ordered list of levels. It is important for them to be ordered because that's what's going to make sure that the views are well on top of each other when we place them in an axonometric, otherwise it won't make much sense. So we're going to create those axonometric views for each level and place them on a sheet. Okay, so let's get going with step number 1, which is to let the user pick a reference 3D view. Now, I was mentioning this earlier, but it's always best to let the user set up their reference 3D view through the Revit UI. They're very used to doing so. It's also much easier to do this like this than through code because you can really adjust the level, the angle to your liking, and also focus on any part of your building you wish. Right. So For this exercise, we're going to start with a view that looks something like this. All right, so we're going to build an input in OkPy to let the users pick this reference view. So what I could do is start with a base drop-down input. That's going to be a good solution because it will provide us with a way to build a drop-down for a single selection for the users. But this is just some dummy input with dummy code, and I don't want to build everything from scratch. I'm going to make things easier for myself and start with the views out of the box drop-down input. The problem here is that we have all the views in the model. So we get the 3D views, the floor plans, the ceiling plans. It's way too much for our users to pick from. So what we want to do is modify this node and make it return only the 3D views to make it a better experience for everyone. So let's rename it first. And also change the description. And then we're going to have to make some small tweaks to the code. And this is why I wanted to start with this input and not from scratch, because there's not going to be much to do here. We have our imports, we have our filtered element collector where we get the views class, and we're also using the where element is not element type filter. This is a very, very important thing because if we have types in our list, it might mess up our code because types have different parameters and methods. We're making sure here that we are not getting the templates as well because views and view templates are the same thing for Revit. And we want to also make sure that, you know, an extra check to the fact that we want the views to not be view templates. We also want them to be 3D views. So we're going to check out the view class in the Revit API, check out their members, and the view elements in the Revit API have a view type property, and that property returns the view type of the view. And this is how we can identify that view type. The view type that it returns is actually an enumeration. It's an enum. It's a comprehensive list of all the view types that we have in Revit, and we need the 3D view type here to make sure that we're only querying the 3D views. So we're going to add an AND statement here and add the view type equal view type dot 3D. This is the extra check. All right. So if we apply this, oh, it's not happy. What's up? Right, view type is not defined. Okay, so in this input, we didn't have the view type class imported, and that's because we don't want to do the wildcard import in order to not import everything for every input. This is just cleaner this way, and it also helps keep things as fast as possible. So I'm just going to import the view type class as well from the Revit API. We have the filtered elements collector, the view type, and there we go. Here's a drop-down input with only the 3D views in the model. Okay, so what we may want to do with an input like this is save it, because it might be useful in many cases, right? Now that we have a couple of options to do so, we could either save it as and save it locally. If we save it locally, we will be able to use it again in another tool without having to recreate it. So that's pretty cool. So yeah, the save as option will go and save it on your computer, but then we can also publish it online. And this is pretty awesome because not only is it going to save this input, but it's also going to make it available to the whole community. If you confirm the publishing of the input, it's going to get published. All right. And yeah, we could take also a little look at the place where those cloud inputs get shared and displayed. So in order to access that, you'll need to go to the File, Menu, then Preferences, and in there we will have access to the local custom input locations. So that's where, locally saving the inputs will store the inputs. You can add other locations if you wish, but by default this will be the one. You can add through this button. We have the online custom input browser. So this is where you get to browse all of the inputs that were published by the community. And it's pretty awesome to see that we have stuff from Anthony Zoutfeld, we have stuff by John Pearson from Parallax team and Design Tech Unraveled. So this is really exciting to watch happen. And I'm hoping that there's going to be more and more by the day. So you can download any input that's been published by anyone. You can also upvote, downvote. This will hopefully help identify the valuable stuff. And here in the Online Custom Inputs Manager, we can manage the online inputs that we have downloaded. So if you want to remove one of those inputs because it's of no use anymore, you can simply come in here and delete them. So I'm deleting these two because I've uploaded a couple of them for the exercise and then re-downloaded them a couple of times. All right, now I have the data export node for input from Anthony Zoutfeld. So cheers, Anthony, if you're watching this. And yeah, this is a node that can be reused. What we're going to do though here is give it a more understandable name for our users for this specific tool, because 3D views does not say that we're actually trying to select a reference 3D view for this tool. And the modifications that I make in here will not be made public, or they won't override the default name and description of the input unless we hit the update button that we have now at the bottom of the window. So when we hit apply, it really only affects this input and this tool. Okay, awesome. Now it's right here. It's still called 3D view when we look for it, but this instance of this input is called select a reference 3D view. Makes much more sense for the use case that we have here. And if we wanted to update these changes, well, now we have these extra features, extra buttons to click on. Okay, so now, again, if you want to hear more about how OkPy interacts with those inputs, I'd strongly suggest you go back and watch episode 1. But for now, I'll just go right ahead and use my inputs dictionary to query this input after I've renamed it. So it's called reference 3D. And yeah, that's the key in the inputs dictionary. Now we need to get the list of ordered levels in the model. So let's store it in a variable called levels and use the most useful thing I believe in the Revit API is filtered elements collector. Doc. So we're collecting on the current document. We're using the level class, and where element is not element type, because we do not want to get level types. That would also mess up our code in many scenarios because they don't have the same methods and attributes as level instances. But what we want is an ordered list of levels. So we're going to create an ordered levels list and use some built-in Python features here. Now this function that we're going to use is called sorted, and sorted, its default, so yeah, it appears in our autocomplete. It tells you what arguments it's expecting. First is the iterable, so that's the list that we want to sort, and then we can also give it a key. If it was just a list of strings or integers, this would be enough because it would know the order due to the inherent value of the items. But since the levels are Revit API objects, we need to specify the key that we're going to sort with. And in order to do so, the autocomplete is a little, it's trying to be too helpful sometimes. We need to make it a little gentler. Okay, so the key attribute here is going to let us specify a function. So we're going to use a lambda function. That's also some built-in Python stuff that you can use here, or in Python in Dynamo, or in any Python development platform. So lambda lets us define a function in place. We don't have to define it anywhere else, which simply say that we want a function that takes whatever object x and returns something based off that x. And in this case, we want the elevation of the levels. So it's going to sort our list of levels based off their elevation. Now, this is exactly what we want. And yeah, we're using the sorted feature. We have our list. Just in order to make sure that this has worked well, we're going to iterate through the ordered levels here. So for L, no, not lambda, just for L in ordered levels, we can print to the console, and we're going to print the name of the levels. I'll just switch to the console to watch the output. Okay, so we get the entry level, first, second floor, third floor, roof, parapet. Seems like our sorting has worked well. No error messages. We can remove this little check here. All right, awesome. Next is to create one axonometric view per level. So in order to do so, we're going to use the view duplicate method that the view class has, and it's pretty similar to what you have with the Revit UI, where you can right click any view and just decide to duplicate it. Let's look at what this method expects. Okay, so it's waiting for a view duplicate option argument. And what these are is simply an enumeration of all the duplication scenarios, exactly the same as through the Revit UI once more, because we have simple duplicate as dependent, or with detailing. We're going to be duplicating our reference 3D view. So that's the first option. I think it's the only one that's going to work here. I don't think as dependent works for 3D views. So let's just go ahead and use the duplicate. So we need to iterate through our list of ordered levels and create one view per level. So for L in ordered levels, we want to get the reference 3D. So yeah, we have already stored it in this variable. It's the one that's going to be picked by the user. So yeah, let's store it in a variable called new view ID, because this method returns the ID of the created view. Reference 3D dot duplicate view duplicate option dot duplicate. All right. And what we can do is also rename it right away. In order to do so, we need to get the actual view, not just the ID. And when we have the ID of an element and we need the actual element, we just go doc.getElement, and we give it the element ID, and that will return the element. So now we have access to the naming, etc. So new view dot name, and we're going to give it a very recognizable prefix. This will be super useful in order to perform some cleaning afterwards. I will get to that. So yeah, this hashtag axo underscore is going to be helpful. And then we're simply going to give it the name of the level. So that should ensure some unicity and also some recognizability. All right. Now, in order to enable this to happen, this creation to happen, I need to start a transaction, because as we've seen in the past, you cannot modify a Revit document outside of a transaction. So we're creating a transaction using the transaction constructor. We specify the document where it needs to be run, then we start it. And at the moment we started, we can also name it OkPy. Let's say, exploded axonometric tool. And this is also going to be showing in the undo redo panels. So that's also cleaner this way. And then we commit the transaction. All right, let's see what happens if we pick the default 3D that we just set up and hit run. We get the view creation per level. That's awesome. So Axo 01 entry level, then level 2, level 3. But right now, we simply duplicated the reference view for each level and renamed those views, but they're essentially the same. We really haven't done anything special. So instead of, we could go back here and cancel this operation before we rerun the tool. But thanks to this naming, it's going to be possible for us to actually clean up the created views every time we run the script. That will make it easier to rerun it as many times as we want and get things updated rather than simply like increment it every time. This will cause issues with naming and many other things. So let's go ahead and run a cleanup routine here at the start before we do anything. So this cleanup is going to need us to create a cleanup transaction where we collect the previously created views. Once more, filtered elements collector is our friend here. So we're going to get all the elements of class view in the current document, where element is not element type, though I think, no type is going to have the same prefix because we're going to be using the name. But anyway, and these, by the way, are all the views in the level, not just the previously created ones. The previously created ones are going to be queried with some filtering here. So little list comprehension in Python, where we iterate through all views. So v in all views, v4 v in all views, if v name, not vars, v. This autocomplete is a little rough. Okay, then starts with, now this is a default Python method to check whether something starts with something, with like some string. And we're going to use our prefix. So that's why I was saying that this would be handy, because now we have very easily identified all the views that were previously created by this tool, right? Now we're going to iterate through those previously created views. So for v in previously created views. And let's go pv just in order to avoid having the same iterators. Oh, it doesn't make a big difference, I think. Doc.delete pv.id. So that's what you do when you want to delete something through the Revit API. You get the current documents and use the delete method and pass the element ID. And this needs to happen inside of a transaction. So transaction for the current document. Let's start it. Let's name it and describe a little bit of what's happening in it. Cleaning up views. All right, so we know. And then we need to commit the transaction when we're done deleting the views. Dot commit. Sweet. Okay, now we should be able to rerun the tool as much as we want. Something's not right. I got a typo Yes. Right, missing the C. And now it works. So that's really cool. So, I mean, it may not show here because we didn't change anything, but if we change the angle and want to regenerate the views based off this reference, there we go. It happens really fast, but it actually deleted the previous views and recreated them based off the new reference 3D view. So that's pretty cool. Now we have a tool that's able to be rerun and updates what it has previously created. All right. So the next step for us here is going to be setting up the section box for those 3D views that we've created. So this time we go with the View 3D class, which inherits from View and is specific to, well, View 3Ds. And it has a convenient method called getSectionBox. It will return a bounding box, which is basically, the biggest shoebox, or sorry, the smallest shoebox you need to fit your building. So we're going to be getting that bounding box. So getting extents of reference 3D views. That's going to be a reference BB, reference bounding box. We'll call it that way. And it's equal to reference 3D.getSectionBox. Now this returns the bounding box, and we're going to need the extents of that bounding box in order to create the extents for each one of our levels. We're going to start from this bounding box here. We're going to get the min point and the max point of the bounding box. That's what defines a bounding box, really. It's their minimum points and maximum points. It's the opposite angles of that parallel shape. And we query them like this. Min equals reference bb dot min and reference bb dot max. Yep, I'm pretty sure that's the way. Bounding box xyz. Yeah, min and max. I just wanted to make sure that it was not min point and max points as it is sometimes. Okay, we have our 2 reference points, and now we're going to generate a level bounding box for each one of our levels. The bounding box class has a constructor that goes just like this. So bounding box xyz. I don't think it expects any arguments. Yeah, okay, and it defaults to a min point that's minus 100x, minus 100y, and minus 100z, and 100, 100, 100 xyz for the max point. So yeah, it doesn't take any arguments and defaults to those values. But what we're going to do is we're going to set those min and max values ourselves using the min and max of the reference 3D view. So we're going to create some min and max that we're going to assign to the min of that level bounding box. And in order to create a point in Revit, simply xyz, that's the constructor for points and vectors. And then we need to give it the x, y, and z values. Now for x and y, we're going to use the exact same values as the reference 3D, because in the x and y directions, we want the exact same points. We simply want to adjust the z values. So we're going to give it min.x. That's how we get the x value of the min point. Then min point y. So those are the x and y points. X and y coordinates for the minimum and maximum points of the bounding box. And then for z, that's where we're going to make something a little different, because we are going to use the level elevation and adjust the height of the bounding box, of the section box, based off the elevation level. All right. But since we don't want it to be exactly adjusted with the level, we'll give it a little -3 here. By the way, the Revit API works in feet, so -3 is -3 feet. We could convert this to other units, but I don't want to get into this in here, especially since it's more complicated than it should be. So let's just give it this -3, which I think will be a good value. It's roughly -1 meter. For those of you who, like me, don't understand anything to feet and inches and all of that crazy stuff. All right, so yeah, we're good to go here with the new min of this level bounding box, x of the reference view, y of the reference view, and the z that we've set up ourselves. And we're going to build a max for this level bounding box following the exact same logic. So it's going to be x, y, z, but we're going to be using the max values, max x, max y, and then for z, again, level elevation, but this time let's go with +3. So we'll get a nice slice of the building that spreads from -3 to +3 in terms of height for each one of our levels. Awesome. So now we need to set the section box of the newly created view using this bounding box that we just created. So yeah, there is a method just for that. So new view, set section box, pretty similar to when we use the get section box. And then we feed it this bounding box. Okay, let's hit run and see what it does. Oops. Reference BB is not defined, line 31. Yep, there's a typo. Forgot an E. Okay, how about now? Sweet. Let's look at our views. Okay, so it's, you know, getting somewhere. But I don't know if you're noticing, but yeah, it's slightly offset. The section box is not exactly the one that we had in our reference view, but there's a reason to that. And I'm going to fix this. The reason for this is that the min and max values that are returned here, they're returned in the coordinate systems of the bounding box. So every element in Revit has what we call a transform. And a transform is basically a coordinate system. And what I'm going to do here is use some of Revit's methods to convert from a coordinate system to another one. And yeah, that's going to solve our issue here. So let's call this reference transform. That's the Revit terminology for this. And we're going to simply get the transform. I think the bounding box has a transform attribute that we can simply query. Yes, it does. All right. So simply reference bb.transform. And then the method is a method of the transform itself. So we're going to go reference transform on each one of those points, the min point and the max point. So reference transform. Let's just look at the methods that the transform has for points. So we have a of point method. All right, applies the transformation to the point and returns the results. Sweet. So we're simply going to use the reference transform that we just queried and then use the of point method to apply this transform to both the min point and the max point. This is a small manipulation here that's necessary to get our bounding boxes aligned. So little extra steps were necessary before we got things nice and aligned. So yeah, we applied this here and we used those points in the following code, so I think we can just hit run here and see the magic happen. What's wrong? All right. I'm trying to, I mean, the code is trying to delete a view that's currently open, so that's not possible, and that's good to know, I guess. But if we go back to our reference view, all right, now it looks exactly how I wanted it to. It's perfectly aligned to my reference 3D view in terms of X and Y, but every view has its elevation settings that align for each level. Now we need to place those views on a sheet. The methods for this are rather straightforward. We first need to create a sheet, right? And for that, so there's a view sheet class in Revit, so that's the class for the sheets. And I believe it has a constructor or a create method. There we go. The create method that takes an element ID on top of the document, and the element ID is for the title block type. All right, so you know, we could hard code some title block here in our code, but I think it would be better to build an input for our users to pick the title block that they want. And this will make this tool a little more flexible too. So I'm going to follow the same logic I did earlier. I'm going to use the view family types out of the box drop down input, and I'm going to modify it in order to only return title block family types, because I don't want to go from scratch. I want to build on top of what's already existing. So here we were querying all the elements of class view family type. I'm going to switch this to a of category logic, and I'm going to use the built-in title block category with the built-in category enumerator. So yeah, the enumerator, again, I mean, I never remember exactly how every category is called and spelled, so I keep going back to apidocs.co, best website in the world. All right, we have the full list here, and we can look for the title blocks. Okay, OST title block, sweet. And also where element is element type this time, because we do want the title block types. We don't want the instances to be in our dropdown. So this filter exists as well, and depending on the context, it's going to be interesting to have it. Okay, awesome. So yeah, let's rename it title block types, all title block family types in the model as drop down for single selection, and let's publish it, because yeah, this is another one of these inputs that could definitely be useful to, well, me and another tool or someone else in the world. So we just published it, made it available to the community, and yeah, this should return. Maybe I should have tried it before I published it, but yeah, it seems to be working fine. And here's the list of title blocks types. That's pretty cool, right? Maybe let's give it a more adapted name for this specific tool. So select title block for the Axonometric sheet. All right. Okay. So yeah, let's go ahead and also let the users pick the sheet number and sheet name using some simple text boxes. This time I go with the text box base. There's not much to customize here. Simply change the name for it to make sense. So yeah, this one is going to be called sheet number. The other one is going to be called sheet name. Okay, And yeah, let's do this now. Sheet create, view sheet create, and then it needs the doc, current document, and the title block, which is actually selected by the users. So let's give it a key, a more recognizable key in our inputs dictionary, and let's store it in a variable. Title block equals inputs, and let's use the title block key, and let's pass the ID of this title block to the view sheet creation line. All right. So we need to add the views. Right. One thing that we didn't do is we didn't create a list where we stored the views that we created. So let's do this right now. Yeah, let's just call it Axonometric views, and initialize the empty list. And every time we create a list in our a view in our iteration, we're simply going to append it to this Axonometric views, because then we need those views in order to place them on the sheets. Or I could have created the sheets beforehand and then added the views as they were being created. Really doesn't matter here. So for view in Axonometric views, we need to create a viewport. So viewport is a Revit class. I believe it has a constructor, public constructor, probably called create. There we go. And what it wants is the document, the view sheet ID, where to be placed, the view ID that is going to be in the viewport, and a XYZ coordinates for the position on the sheet. So let's give it all of that. Create, doc, we already have that. The sheet ID is the one we just created. The title block, the view ID is the one we're iterating with, and then an XYZ. And then we're just simply going to give it 0 and then a Y variable that we're going to increment as we go. Because in sheets, in sheets, X and Y correspond to the 2D directions, right? So basically the plane of your screen. So Y is going to be equal to 0 at first. That's the initialization before we start the iteration. And X is this direction, Y is this direction. So X is always going to be 0, and we'll replace this by hand afterwards. Z can stay at 0, because there's no real 3D in sheets. So Y is equal to 0 at first, but then every time we iterate, we're going to add a 0.5 to its value. So it's going to be worth 0, then 0.5, then 1, then 1.5, and so on. And it will keep incrementing 0.5 as long as we have views in our axonometric views. Okay, so yeah, this is going to make sure that the views are placed on top of each other on our sheet. We need to pick some inputs before we hit run. Okay, this should do it. Yeah, we didn't actually rename the sheets and set also its number, so let's do that. Sheet name equals inputs. I'm just going to query those values straight from the dictionary inputs. Inputs. Yeah, let's rename it as well in order for it to make more sense. Nice. Something went wrong. What's up? Cannot be deleted. All right, we're again trying to delete a view that's currently open. So let's close those views before, or go back to another view before we run the tool. Right, it looks like it was run successfully. Let's see, let's look at our sheet. It's been created, it has some views. That is not bad at all. All right. There is, yeah, some of the views are a little misaligned. There's a reason to that. Yeah, should have thought of that earlier. There's a reason to that because the viewports, they're placed based off their center. And if there's not the same amount of geometry, then that viewport is going to be a little smaller, like it is for the parapets and for the levels. So we need to make sure that they all have the exact same crop box. Yeah, the same as the reference 3D view. That will make everything aligned perfectly. So let's go ahead and make sure that all of this aligns well. What we're going to do is activate the crop view for this reference view. And yeah, we could or not make the crop region visible, but what's important is that it's active, because if it is activated for the reference 3D, then we're certain that it's going to be the same for the other views because they're all created from the reference 3D. So we're going to go back at the moment we query the reference 3D. So right here. And when we're getting the extents of the reference 3D, we're going to make sure that the section box, I think the views have a section box attribute. Let's make sure. Right, crop box active, crop box visible. Let's set those two values for our reference 3D view. So we go reference 3D dot crop box active, and we set this to true. It will always make sure that the crop box is activated, even though the users don't think about it. And then we're going to make sure that that crop box is not visible because, well, it's just cleaner that way. So we set that to false. Okay, I think we're good to go now. So I didn't do anything to delete the sheets the same way I did for the views. We could do that. I'm not going to do it today. I'm just going to run this with a different sheet number. Nice. Seems to have been run successfully. We have a new sheet. We have some views placed on that sheet, I can tell. And they all perfectly aligned. Now that's pretty nice, right? And we only have like 4 levels here, so I mean, it still is hard to get them perfectly aligned, and like it's cumbersome to duplicate the views, etc. So it's already nice to have them that way. But imagine you're working on a tower. That can really save some time. Just going to use the same templates on all views in order to make them a little smaller so they fit better on the page. I'm going to turn off the cast shadows. They don't make much sense in this type of representation. Nice. We also have the parapet, which is, I mean, not necessary. It's just a sort of a fake level. The roof is, the roof of the building is definitely enough. Okay, so now we can save this tool, make it something reusable, shareable. I'm going to save it under, the folder I made for this episode. It's called Exploded Axonometric Creation Tool. Nice. What we can also do is give it a description. This is something that will make the UI more user-friendly, even more user-friendly, because it's more information for the users when they open this tool through the user interface, which I will show you in a couple of seconds. So creating an exploded axonometric from a reference 3D view. Okay, let's save these changes. And now through Orkestra, what we can do is switch to the OkPy content. All of this is local. Here it is under episode 2, right click, add to ribbon. And if we go back to the OkPy tab, here it is. So we have a ribbon button for this tool, and clicking it will open the tool in the user mode. So no editor, just the inputs, some descriptions, some tooltips, and everything they need to use this tool without having to worry too much about what's happening on the back end. Maybe one last thing before I end this video is just letting you know that you can reach out through the forum, and also that all the content will be made available. So by content, I mean the download files, etc. The forum is reachable through our website, so www.orkestra.online. And if you come across anything trying to get all of this to work, or if you have any question or any custom tool that you're trying to build and would like to get some help with, feel free to reach out. That's it for today. Thank you so much for watching, and stay tuned for episode 3, 4, and 5, as we're going to build on top of this. All right, you take care.